Assalamualaikum warahmatullahi wabarakatuh, and hello, we are from Group 5, and today we'll be presenting the usage of GIS software and WebGIS. This is the list of our group members, all 5 of them. They will be introducing themselves when the times come. Okay, first off, my name is Muhammad Razid Kamrul Zaman, number matrix E24A3310, and I will be presenting the first part of our presentation, a little bit of introduction. So, first off, what's the problem? What is GIS? Why we use them? Well, the Earth is a very vast planet. It's a large planet, and to understand the environment or the special information, we need a software that can help us create and store and manage such information way. So let's bring us to the objective of this presentation, which is to explore the usage of GIS software and WebGIS software, also to start using GIS software to solve special problem, and finally understanding and practicing digital skill in using the GIS software. Now, how about we take a look at the 2 types of GIS software that we'll be using in this project in the next slide. So let's take a look at this. What is GIS? GIS is a short form for Geographical Information System. It's a software which we can use to store special information, special data, manage special data, or even translating those data into a more readable form of information such as maps. In this project, we actually use a specific software specific software called QGIS. It's a desktop GIS, which means run natively on the computer's hardware. So, what is QGIS? It's a short form for Quantum Geographical Information Systems. It's a free and open source software, so everyone can download it and install it on their laptop or PC, personal computers. Even though it's free, it contains many features such as support for vector, raster, web-based data such as shapefiles, satellite imagery, and also OpenStreetMaps. It also helps providing tools, by providing tools such as spatial analysis, also a bunch of plugins that we can download and install in it, including attributes, queries, table classification, and overlay analysis. This software will help to create a strong map design and visualization that can be easily understandable even by amateur eyes. Also, such as the easy to use and easy to incorporate symbology, labels, or create a choropleth maps, which is the type of map that we are using in this project. Actually, is one of us. It's very much widely used in environmental, also geoscience field, to maps the environments to help locate such things such as minerals or labeling them in the maps. Though this is not the only one, this is not the only software that we use. We also use a web-based GIS, which is on the another slides. Alright, so web-based GIS, just like its name, is web-based or browser-based. Unlike the desktop GIS, which need to run on a local software natively on a hardware, web-based GIS is usually run on a server. Run on a server, so it's a very light to use. Everyone can use it. You don't need a beefy computer. Even phone can use a web-based GIS. it's an easy to use way to show maps design and stuff like that. It allows us because it allows user to zoom, pan and interact with the map, the basic features. It also work well with OpenStreetMap, which we use a lot with QGIS, and because how light it is to run, is improve accessibility and scalability, so very easy to use. And the GIS output, everyone can see the GIS outputs of it. Alright, now that we know the type of software that we use in these projects. Oh yeah, before that, the one that we use, there's a lot of web-based GIS software. The one that we use is called Leaflet, and all those perks that I say before apply to Leaflet. Alright, now that we know the kind of software that we use in this project, let us take a look at the technical demonstration of this software, or how we, all 5 of us, make a map using a map of iron ore extraction. Each one of us is using different years data to create a map based on iron extraction by states in Malaysia. Alright, my friends will take over for this part.
Hello, my name is Muhammad Aikal bin Halimi. My number matric is E24A3132. I will present technical demonstration iron ore distribution in Malaysia 2020. For the technical demonstration, QGIS version 3.44 was used as the main GIS platform. OpenStreetMap was first loaded as the base map to provide geographic context for the analysis. The iron ore data set for the year 2020 was then imported into QGIS using the add data function. This step allowed the spatial data to be displayed and prepared for further processing. Next, the attribute table was examined to understand the structure of the iron ore dataset. Relevant attribute fields are reviewed and organized to ensure the data was consistent and suitable for spatial analysis. This process is important because accurate attribute data is required to produce meaningful map visualization. After the data was prepared, graduated symbology was applied to create a choropleth map. This method classifies the iron ore data into different value range, making spatial pattern easier to interpret. As a result, variation in iron ore distribution across Malaysia can be clearly visualized. Finally, the completed map was exported using the QGIS to web plugin to produce a WebGIS version. This allows the map to be viewed interactively through a web browser without requiring GIS software. The WebGIS output improves accessibility and enables spatial information to be shared with a wider audience. Thank you.
Hello and Assalamualaikum. My name is Nik Muhammad Hafiz bin Hussein. My matric number is E24A3486. And I'm gonna present it for my part in this presentation about application to geoscience. Iron ore plays an important role in Malaysia minings and also industrial development. However, uncontrolled or poorly planned mining activities may cause environmental problems such as land degradation, deforestation. GIS is needed because iron ore distribution varies especially across states and districts, and spatial analysis help us identify high concentration areas and assess their surrounding environmental context. Next, I will present a study titled GIS, analysis and visualization of iron ore distribution. This study focused on the use of Geographic Information System, or we call as GIS, as an analysis and visualization tool to understand the distribution of iron ore and its relationship to spatial and environmental factors. For the data, iron ore production data for Malaysia was imported into QGIS and linked to spatial units using the attribute table. This allows the data to be analyzed geographically rather than only in tabular form. QGIS software was used for mapping and spatial visualization. It allow us to manage layers, edit attribute, and create thematic map such as choropleth map to show iron ore distribution. Meanwhile, OpenStreetMap was used as the base map in QGIS. It displays roads, rivers, settlements, and land features, which help us interpret the location of iron ore areas and understand their accessibility and surrounding environment. To analyze land use, the Quick OSM plugin was used to extract land use features such as forest area, wood-out zones, and water bodies. This helps identify potential environmental impact near iron ore mining location. Finally, QGIS 12 was used to publish the result as an interactive web GIS. This allows users to zoom, click, and explore iron ore distribution and land use information interactively, making the data more accessible and useful for decision making. That's all from me.
Well, so back to me again. We'll be presenting a little bit of data analysis based on the maps that we all created using QGIS, which is the map of iron ore extraction. First off, let's start with my friend's AMA maps, which is the 2017 based on 2017 data of iron ore extraction in Malaysia. This is the first year that we took from actually it's the second year that the second oldest data that we can find. And here we can see the let's use this map as a baseline. Here we can see that Pahang, the Pahang, Terengganu, and Johor are the primary producer or extractor of iron ore. Keep this trend in mind actually. So with this map being the baseline, let's see the other years and compare it. Now we are looking at the data of 2018. 2018 maps. This one is made by me, and we can definitely see the gradients of these, the gradient of colors of this map, which we can see that actually there's a decrease from 2017 to 2018. So instead of the three producers, there is some other more producer, which we can see Kelantan and Kedah being a more a minor producer. So definitely contributes to it. Alright, now let's take a look at the other years and compare it. Now we have 2019 map by my friend Nick Muhammad Hafiz. There's not a lot of change here in 2019 actually. As we can see, a lot of the same state, a lot of the production, the output is not that much different from last year. Oh yeah, by the way, I want to add some things before. The Gis 9 Negeri Sembilan and Sarawak in 2016 produced iron ore. Though after that, they don't really produce it. Actually, keep in mind that I will keep in mind about that information as I will explain a bit later. Alright, now let's take a look at another maps and compare. So this is the map for 2020. As you can see again, not so much difference. This is one is again by my friend Muhammad Aikal. But there's a geological explanation for this at the end. Let's see the trend first. This is the last of our data set made by my friend Muhammad Sufian. And also, I forgot to mention, there's quite a decrease, a steep decrease between 2020 and 2021 production. Probably because of COVID. 2020 is actually the peak years of iron ore production in Malaysia. Now that we have seen all the maps from 2017 up to 2021, we can see a little bit of difference, besides as Kelantan and Kedah start producing more ores, and Johor have a bit of decline in producing ores, but Terengganu has a bit of upward trend in it. Pahang remain the top. They are the producer of a lot of minerals and ore in Malaysia, after all. We can really see how geologies affect it, other than social development such as urbanization, which we can see actually in Johor. The urbanization definitely affect the mining sector in it, as the economy grow more into what we say a white collar or corporate economy instead of more blue collar mining economy. But geology definitely play an important part. We can see this in Sabah, Sarawak. Sarawak only has a little bit of iron ore. It's already depleted, so it's Negeri Sembilan actually. But I'm gonna focus on the Borneo parts in Sabah, Sarawak, which has let's say a little bit of a different geological features than the western Malaysia is. So we can see that there's really no iron ore production in Sabah and Sarawak anymore, at least. In west coast of Malaysia, we can actually see some in Perak. This year 2021 is only the first year where Perak produced iron ore in such a long time. Perak was famous for tin ore, but iron ore is quite new, and this 2021 is the first year that they produce it, extract it. We can see actually that in West Malaysia is not really about geology because meanwhile there's quite different between East Coast and West Coast in terms of geology. There's also quite a similarity, and some of the material can really be found all across the West Peninsula Malaysia. But it's more towards the social aspect, as we can see in Selangor, Negeri Sembilan and Melaka, which is more urbanized, economically more urbanized. They don't really mine the stuff for their main economical income. Meanwhile, in Eastern Malaysia, you can really see it, as they have more rural area or undeveloped land, and thus more extraction of minerals. As we can see, how from this actually we can see how the GIS help us understand, even if the data don't really change much, it help us understand a trend, or say it's a pattern for us that if we see only just in numbers, will probably be hard to comprehend. This helps us understand the geological features, the geological effects, or the social aspect of how iron ore produce, being extracted on, and so on and so on. Alright, I think that's it. I think I will pass it to the next presenter. Thank you.
Hi, my name is Muhammad Ahmad Ashmawi bin Muhammad Sani, nama matric E24A3305. So, for my part, I would like to talk about the comparison of desktop GIS and web GIS. So, for this section, compared to GIS compared to desktop JS and web JS in terms of usability, scalability, and accessibility, as well as their limitation and potential improvement. So, firstly, in terms of usability, desktop JS software such as ArcGIS Desktop and QGIS is mainly designed for professional users who require advanced pattern analysis and data processing capabilities. Desktop GIS provide powerful tool for geoprocessing, modeling, and detailed cartographic design. However, it has a steep learning curve and requires software installation and local data management, which may be challenging for beginners. So in contrast, WebGIS focuses on simplicity and ease of use. It can be accessed directly through a web browser and is more suitable for non-technical users. WebGIS often offers a simplified tool for viewing, querying, and basic pattern analysis. Although its usability is higher for general user, advanced analytical functions are often limited compared to the just desktop JS. So secondly, in terms of scalability, desktop JS has limitation because it depends on the processing power and storage capacity of a single computer. Handling large datasets or supporting multiple users simultaneously may reduce performance and require costly hardware upgrade. On the other hand, WebGIS is highly scalable due to its server-based and cloud computing infrastructure. It can efficiently manage large party dataset and support multiple users at the same time. Cloud-based platform allow systems resource to be adjusted based on user demand, making WebGIS more suitable for large organization and public access. So, next is regarding accessibility. WebGIS offers a significant advantage. It allows users to access special data anytime and everywhere using an internet connection and a compatible device. This improves data sharing, collaboration, and decision making across different locations. In comparison, desktop JS has limitation. Accessibility as it requires software installation, license, and specific hardware. So, in terms of limitation, desktop JS is often expensive due to software license and hardware requirement. However, desktop JS can be improved by integrating more cloud-based features, enhancing data sharing, and simplify user interface to support new user. Meanwhile, WebGIS has limitation in advanced pattern analysis and customization. Its performance depends on internet connectivity and server reliability, and data security can be concerned for sensitive information. So that's all from me. Thank you.
This is the second slide for the comparison.
My name is Muhammad Sufyan Deswai. My number metric is E24A3133. I will talk about a digital skill showcase. This project demonstrates a comprehensive application of a digital skill GIS through the integration of a desktop GIS and web GIS technologies to analyze iron ore mining data in Malaysia from 2017 to 2021. Firstly, desktop GIS, or we familiar with the words QGIS, was used for data preparation and spatial analysis. Mining data for iron ore extraction over a 5-year period were organized and structured using a attribute table. A spatial data set were layered according to administration boundaries at a state level, enabling a temporal spatial comprehension of mining activity. Correlate mining techniques were applied to visualize a variation of iron ore mining intensity across a different state. Secondly, a spatial visualization skill were enhanced through effective map design principles include appropriate a symbol, a color ingredient, and classification method. The use of a gratitude color schemes allow a clear interpretation of mining intensity, where dark color represent high level of iron ore mining activity. Intensity cartography elements such as a clear boundary and consistent color scaling were maintained to ensure map reliability and interpretability. Furthermore, WebGIS skills were demonstrated through the publishing of the spatial output where QGIS web with the open layer platform. These 5-year iron ore mining maps were converted from a desktop GIS environment into an interactive web-based map. This process enabling border accessibility, allowing user to view a spatial mining pattern directly through a web browser without requiring a specialized GIS software. Overall, the integration of spatial data management, map visualization, spatial analysis, and web-based map publishing highlights a strong digitalization comprehensive in GIS. This digital skill support effective spatial decision making and demonstration of a practical application of GIS technologies in analyzing a real-world environment and resource-based issue. Next.
In conclusion, GIS is an effective tool for analyzing and visualizing spatial data related to mineral resources. QGIS allows iron ore distribution in Malaysia to be efficiently processed and mapped. The use of WebGIS further improves accessibility by enabling spatial information to be shared online. Overall, this project highlights the importance of GIS and digital skills in supporting environmental management and resource planning. Thank you.
This is our references. And finally, I want to say thank you for listening to our presentation.